Hello. Yep, as Matt just said, my name's Adam Wilson. I'm the Principal SRE at Comply Advantage. I'm not here announcing any cool products of any kind, but I'm just telling you how we've ended up using quite a cool product and how we went from on-prem Grafana to cloud Grafana with a little bump in the middle. Just for a bit of background on myself, I'm actually from Medway in Kent. It's a lovely picture of someone from Medway in. Lovely picture of Rochester, which is the only place in the UK, I think, that has actually managed to lose its city status. There's quite an interesting Tom Scott video on that if you want to know the details behind that. And purely based on that, I ended up moving to Brighton, and that's a lovely picture of Concord 2 in Brighton, which is where I spend as much of my free time as I possibly can. I play drums and go to as many gigs as I can. But anyway, when I'm not at gigs and playing drums, I work for a company called Comply Advantage. We're all about trying to find bad guys in the financial system. So we kind of work with a lot of different fintechs across the globe, really, to try and find anti-money laundering or help provide anti-money laundering. And yeah, like I said, try and root out anybody in the financial system that we'd rather wasn't there. So after all of that spiel, I'm going to talk about what we've ended up doing with observability. And yeah, I gave it away in the title of the talk, really, which is that I did a gigantic observability migration with the entire company, got everybody onto one vendor, which I'm not going to name, but there's some clues hidden throughout the slideshow, and 10 points to anyone that can work out which observability vendor we were using in the middle of this process. And just as we'd finished that project, I got the enviable task of turning around to the entire company and saying, well, guess what? We're about to do it again. And we've ended up now migrating onto Grafana Cloud, which is why I'm here. So in order to talk about all of that, I'm going to break down a million different ways of breaking down the parts of an observability system, but the three things that I'm interested in today are how we export data from our systems, our applications, and the various different things that we want to collect information about, how we collect that information, and then how we ship that into our storage, which has a big impact on how we end up querying the data. So why did we end up migrating twice, and why migrate or think about changing your observability stack at all? This is one of my favorite diagrams ever. I bring it up very, very regularly. Simply because, so if anybody doesn't recognize this, this comes from the Google SRE book. And this is kind of like their summary of all of the different, like the Maslow's hierarchy of needs. This is like the Maslow's hierarchy of SRE. And the bottom three parts of this pyramid are all directly related to, or kind of directly tied into, your observability stack. So for me, it's all about making sure that you absolutely nail the bottom parts of this stack before you start trying to do too much at the top and start trying to be too clever. I'm a really big believer in absolutely nailing those basics before you go too crazy. So to give you an idea of like our infrastructure and what we're dealing with, at the moment, we deal with about that many spans per day. That doesn't include the spans that are flowing through Istio, because we've had to sample them all away because there's just so many of them and they weren't giving us the information that we actually cared about at the time. So that's taken directly from our span metrics, and I'll talk a little bit more about our span metrics later. We've got about 41 Kubernetes clusters, that many nodes. About 20% we reckon of our metric series are in OpenTelemetry, the rest of them are in Prometheus. And to give you an idea of the size of some of our on-prem Prometheus servers that are still hanging around, this is a screenshot from our Argo CD. So you can see there's 2 replicas in the stateful set, 110 gigs of memory, and we're requesting 4 CPUs. So that, in terms of like the number of Prometheus servers, I'm not sure if they're still in every single cluster, but yeah, we're talking about 82. That'll become relevant later. So our starting point, where do we start off? We started with an on-prem Grafana, and this is a basic overview, very high level diagram of what our observability stack looked like when I first joined the company. It was set up like this for a reason, and it's got a little 41x over there on the right-hand side, because basically there was no federation. Everything here was deployed into every single cluster. So if you wanted to know about something that was going on across 2 different clusters, you were logging into, let's have a look there. So you're logging into Grafana, you're probably running some kubectl commands directly against the Kubernetes API as well, to understand what was going on in bits that hadn't made it through because there was an error in the Fluent stack somewhere. So yeah, in terms of like how everything worked, we had what I felt was like all of the constituent parts of a great open source observability stack, but just not really serving us. During an incident, you had to hold all of that information in your head, go into one tab, then the next tab, then the next tab. And that was all going on with people trying to put screenshots from K9s, which is something people use for kubectl commands on the command line. So yeah, K9 screenshots were flying across Slack all over the place, which is not great because you can't click on them and get anything out of them, really. You just have to take their word for it that they haven't engineered that, or they've run the right K9s commands. Basically at the end of the day, we had too many people with too much access to our production clusters. And in a fintech that's focused on compliance and security and data security, that wasn't going to hold up. And also just basically because of the culture around observability at the time, everybody wanted their logs forever. They wanted more and more and more metrics. So the Prometheus servers, the reason why there's 2 replicas is because they'd fall over constantly. So when I first joined, I haven't got the exact data because we were very bad at collecting data back then. But basically every single day I had an SRE who was off because they'd been up all night trying to keep the Prometheus servers up because they'd just constantly fall over. Anyway, so that's where we were. And this is what it looked like during an incident. There you go. So you've got tabs opening and you had to try and collect this context and go from one tab to the next and look at all the different things and try and work out what was going on. Right, there we go. So, started looking into this thing called OpenTelemetry. I'm going to very briefly, I'm sure most of you here know what OpenTelemetry is, but for anybody who doesn't, it covers traces, metrics, and logs. It didn't when we first started using it, but logs has come in more recently. It really is geared everything around traces as like a first-class citizen within observability. It allows you to do drop-in instrumentation, so you can start off with just a few lines of code, get maximum benefit from it, and then when you've kind of sold the idea of using OpenTelemetry to your organization, people then, and I can tell you this from experience, people start to use it more and more and more, and they want more out of it because they start to realize the power of it. But often trying to get over that first hurdle, the drop-in instrumentation is absolutely key. And another thing that was really important to us is that it was open source and vendor neutral. And we'll be talking a bit more about the vendor neutrality as this talk goes on. But that fact that it was open source was really important to us. We're a company with a big history of using as much open source technology as we possibly can. We contribute regularly back to open source. Our engineers like to jump into the GitHub and find out if something isn't working, and we're sure it's a bug in the systems that we're using. We want to go and find the bug, raise an issue, raise a PR, see what we can do to help. So yeah, this was really key for us in terms of, OpenTelemetry came about as a fusion of open tracing and open census. I'm doing a massive whistle-stop tour through this, by the way, if you want to know any more of the details. I can bang on about this forever and ever and ever. Anyway, so yeah, this is what's ended up running for us. So a big piece of the OpenTelemetry ecosystem, for anybody who's not already using it, is the OpenTelemetry collector. And this is a visualization that I've pulled from a tool called OTelBin, which if you're using the collector, is a really cool tool, interesting one. So the collector is a Go binary that basically absorbs a hell of a lot of different observability data types. So it can absorb, for our case, we've got open census and pure OpenTelemetry coming in. You can then run a lot of different processors on it within the collector itself, and then you can export to all sorts of different places. For us, I think what have I got one there doing to the load balancing exporter, which again, we'll talk a bit more about later, and one going out to OTel HTTP. So the OpenTelemetry protocol works over at HTTP or gRPC. This one is exporting via HTTP. And at the top there is a pipeline that's running traces. And I think the second one is doing metrics from, I can't quite read the slide, but it's probably metrics. So yeah, that is all I want to say on that. So in terms of like what this looks like in the backend, this is a quick screenshot from Grafana Cloud, just in case anybody isn't already using distributed tracing in their Grafana Cloud instances. This is actually just touching one application, but applications don't run on their own. In our Kubernetes clusters, they've got Istio gateways that the requests touch before they come into the application pod. Then when it hits the app, so this top one right at the top here is the Istio gateway. Then underneath that, in a different color, we've got the Istio proxy, which is a sidecar that runs inside the same pod as our application. And then all of these other little bits and bobs underneath are the application operations that are happening within the app. So the whole thing, to keep us all on the same page, that whole thing is called a trace, and each of the different bits underneath it are called spans. So they're all tied together with IDs, and all of this is just driven through request headers set out by the OpenTelemetry schema. So, yeah, I'd mentioned there was going to be a few clues, and if anyone can guess who we ended up migrating to, but I don't want to get sued, so I haven't got anyone's actual logo on there. So anyway, so in terms of how this works for our purposes internally, we have our app pods. So in this case, we've got a Kotlin app, and it's got the OpenTelemetry SDK running inside the app pod that's over there on the left-hand side. And this developer has actually read my documentation and added the annotations that I asked them to their application pods. So well done them, 10 out of 10. And what that happens over here, we've got the OpenTelemetry operator, which has a number of CRDs. So in ComplyAdvantage, we've got a dedicated observability team, and they are able to control the deployment of the operator, and they deploy the configuration that's in these sidecars. And what the operator will do is actually inject the OpenTelemetry collector binary into the application pod, sitting alongside the application itself. So it's the exact same binary. Every time you see the OpenTelemetry logo on this slide, it's the same Go binary with slightly different configuration. So that's what's really cool about them. You can sync, you can sort of point one to the next, and you can build pipelines that feed into pipelines that feed into pipelines. Anyway, what happened for our purposes was we tried to keep it as simple as possible. App exports to local host, hopefully 4317 on the gRPC OpenTelemetry protocol. Endpoint, there's a sidecar sitting listening there. It's going to chat to the OpenTelemetry, what we call the OTel gateway, via Istio. That's what the little sailing boat is, if anyone's not familiar with that logo. So anyway, everything goes out. So what this means is that the observability team are able to control the sidecar config to make sure that no one does anything silly there. But you know, if we trust an application developer, they might be able to add that config themselves to their Helm chart. The thing that we really care about, though, is the OpenTelemetry gateway, and that's where we have our sort of final controls in place. We make sure that we're tagging it with the right environment. When I first started migrating, we ended up with like a drop-down list in our UI of like 10,000 different environments, because everybody across the company was deciding, no, hang on, that's not a name, so that's QA01, and that's not Playground, that's, you know, QA whatever I've decided it is today. So we tell them, we don't care about that anymore. We're going to tell you what the environment's called. So we have 3 environments in our drop-downs, which makes things 10 times easier when we're communicating across the company. Makes things easier for our support teams, and more importantly for my boss and his boss, to you know, the people that pay our money. Anyway, so then how do we handle everything else? So I mentioned at the time early on, we didn't trust OpenTelemetry with logs, and I don't think OpenTelemetry trusted itself with logs. So we did logs via the unknown vendors' proprietary agents. So we tried to keep things as open source as we possibly could, but we did have, you know, some necessary evils, and we used that to ship logs. What else did I want to say there? Yeah, I think that's it for that. So Very soon after we started implementing all of that, I started having lots and lots of conversations with people about sampling. And this is one of the more interesting things that has changed most recently, has been that people have started to get on board with the fact that sampling is going to happen, whether you like it or not. No application developer seems to want any of their application operations to be sampled. But if anybody here is running, a non-trivial observability infrastructure, you're probably going to be sampling, or you've got way more money than I have to play with. So yeah, but anyway, in most cases, you do not need every single one of your traces. You need an example of what works, and then during an incident, you need an example of something that went wrong, and you can compare the two and go, that's probably the issue. So yeah, very quick on sampling. I don't have the time to go into detail, but I can talk about this all day. Early on, that first diagram that you were just looking at, we were using what's called probabilistic sampling. So effectively, every time a trace hits our gateway, we roll a dice, and if the numbers come up the way we want, we sample it away, and if they don't, we send it onto our backend. We've actually moved to, so probabilistic is really good because it's very easy to do. So we had so many different things going on. We were doing the first migration. So as the observability team, we didn't have time to get really complicated. And we were actually able to use some of the tools that were in the vendor that we were using at the time to get away with just using as much probabilistic sampling as possible, because the vendor that we were using would sample our data for us, which meant that we could keep our infrastructure internally quite simple. But yeah, as time went on, we ended up moving to Grafana Cloud. Anyway, timeline of migration on the first migration took us ages. As I don't want to go into the details of it. It doesn't really matter to any of you. I don't think you're going to get much out of how long it took us to migrate to a vendor that we're not here to talk about today. But just to talk really, really quickly, some of the things that took the most time. I always say, I can reprogram computers tomorrow. They do what I tell them to. It takes you about 18 months to 2 years to reprogram the people. And in any proper observability infrastructure, the people are, a massive key aspect of getting this stuff to work properly. So yeah. It was a long, what I'm trying to say with this slide is it took us many, many months to migrate. There you go. That's all we need to know there. So anyway, we're on Grafana Cloud now. So yeah, after that first migration, I'll give it, so some of the reasons that we ended up moving were more around like our feeling around the culture of this other vendor and the culture that we had internally. And it was very much like we were talking different languages. And as a result, the relationship with this vendor didn't go very well. And started to kind of looking around at different people that we could use for our observability backend now that we were in OpenTelemetry, and we're vendor neutral. We could migrate on a whim, like for zero cost. So yeah, we started looking around at different companies, and as soon as I started talking to Grafana again, it made absolute sense to migrate to work with those guys. They came from an open source background, a similar size in terms, or more similar than with our previous vendor to us. And as soon as I kind of got a lot of our technical teams talking with some of their technical teams, spoke to Tom as part of the onboarding process, and everything gelled much, much, much better. So anyway. Moving swiftly on, in terms of what we needed to do, though, to migrate to Grafana with our vendor-neutral OpenTelemetry that wasn't that vendor-neutral at all, we had to solve for our sampling issues that we didn't need to solve to begin with. So we actually had to implement a much more complex setup of our OpenTelemetry gateways. This is where the load balancing exporter came in. And yeah, so what we do now is similar kind of thing, we get the stuff out of the apps, they dump all sorts of rubbish. It goes into our gateways, and the gateways now use something called span metrics. So every single trace that flows through that first layer of OpenTelemetry gateways, we extract all of the metadata and the numbers and the metrics about it. We ship them straight to Grafana Cloud. Then the first layer of OpenTelemetry gateways then uses the load balancing exporter to send all of the spans from the same trace into the second layer of OpenTelemetry gateways, where we make our sampling decisions. And this is important because both of these are run as Kubernetes deployments, and we need some kind of way of basically, we're hacking state into our observability infrastructure at the moment using request headers. We're constantly debating this though, so if anybody wants to come up and talk with me, I've got a couple of guys from my team here as well. Edwin's in the audience who put a lot of this together, so we're always happy to have a conversation about anybody else's experience with running this kind of stuff, and it'd be cool to bounce some ideas back and forth. But we do, we use all of this, and we've swapped in the Grafana agent where we were using a proprietary agent previously. And it dropped in quite neatly. It does the same thing that we did with the proprietary agent stuff. It handles the logs for us. And actually what we've done is we've added Prometheus running in agent mode back into our clusters to handle our metrics, specifically for the Prometheus endpoints. So I've got a little picture of RabbitMQ there that runs on some of our nodes, and we can scrape the RabbitMQ metrics and ship them up to Grafana Cloud along with everything else. So that's what our infrastructure looks like at the moment. So all of those changes that I was talking about there, like what changed across the organization, like as we did these migrations? And I think the big thing for us was the change in the way that people started to tell stories with data. So these screenshots are from an earlier talk that I used to give. And it's basically, so we've got the trace on the left-hand side there, and we extract the metrics from the trace, and we're able to build pie charts. What I found was that these pie charts actually opened up a conversation across the organization that had never happened before. Because previously, when people used to talk about, like, for example, when our CEO wanted to talk to us and say, how many searches were run across the systems? They'd get some kind of complex answer, well, we've got 300 HTTP responses from this system, and actually, no, only 30% of our requests go via that service, so we have to add that to that and extract with this, and I don't know really. Start talking about traces, because the traces don't matter about which kind of route the operation took through your infrastructure, so you're able to answer very simple questions. How many searches were run? This many. And this is the breakdown by customer. That's actually fake customer IDs up there. So hopefully I've not revealed anything too proprietary. But anyway, the cool thing about this was the CEO could go from our engineering infrastructure data and go and have conversations with our customers and our partners and going, hang on a minute, that discount that I gave you last year, this is quite an interesting pie chart considering how many searches you're running on my infrastructure. Is this really the best relationship for us to take into the next year? And just being able to have that impact on product, on sales, on all of that kind of side of the business, just from getting some request headers into our applications was revolutionary, really. This is just going to be a quick slide. It's basically, in terms of like pulling off the migrations and then migrating again, it's a standard IT change management project. So identify your allies. Every time people come up with problems, because they will, you need a team that they know they can go to, solve the problems quickly. We actually ended up building an observability team, as I mentioned earlier, purely to do, they're not just there to do migrations, because we're not doing any more. Like, I'm done now. I think we've all aged about 10 years. But yeah, so you just need the team there so that you can solve the problems quickly, help people with any of the questions that they have. We actually got 2 Slack channels, one of them for like tech supporty type questions and one for just general observability discussions, so that people can go, has anybody solved this problem before? Or across the org, like, how do people think we should get this into the Python data science teams? How do we do tracing there? How does it work? And people that aren't anything to do with the observability team can just chat about observability, and I can keep an eye and go, oh, that's an interesting conversation. And yeah, we try to dog food as much of our stuff as we possibly can. Like, we should be the experts at using whatever we're trying to get everybody else to use. What else have I got coming up? Yes. So yeah. So apparently I've completely got the slides in the wrong order. So this is a bit meandering and disorganized, much like the migrations were, but we pulled it off, so just work with me here. So these were the concerns I was talking about before. We started to use more and more of the previous vendors' proprietary technology. And this is the thing that you do need to bear in mind when you're starting to use things like OpenTelemetry and it starts talking about vendor neutrality, is it's like the technology might work with multiple vendors, but can you? And do you end up in a place where you're like, actually, I quite like this particular vendor's magic, like some of the features that Grafana were announcing earlier. As you start to bake more and more and you start to rely more and more on those features, you don't need to be like, oh my God, like we're not vendor neutral at all. Like you can migrate, you just have to bear that in mind. Yeah, and we actually got quite a lot out of implementing spam metrics. We didn't have to do spam metrics before. But yeah, it's one of those things to bear in mind. I'm just providing food for thought here. Yeah, that's an AI diagram. So I'm not quite as good at generating AI slides as the Grafana team are, so this is as good as I could get. I think most of the words are actually real words in that as well. So yeah, that was the timeline of our migration onto Grafana Cloud. It was much shorter because we were using OpenTelemetry, so we didn't need to re-implement the SDKs again. So yeah, we've reached the end. And I'm going to reflect a little bit on some of the things that happened throughout the migration. So yeah, we've ended up needing to build more and more tooling as we went from the previous vendor into Grafana Cloud. So, bear that in mind. We originally did a lot of metric under budgeting. As we sort of started to move into Grafana, we ended up with way too many infrastructure metrics. This is one of the reasons why we started we've turned off the Prometheus metrics that come out of our OpenTelemetry sidecars. We've turned off the spam metrics that are generated from our SGO proxies, because that's not, they weren't giving us the story that we wanted to generate with our data. That was just not interesting enough for us at the time, or currently it's not. But we're going to continuously review this side of things. The other problem with moving from on-prem to cloud, especially in the setup that we had, was we had 41 different clusters, and yeah, within each cluster we had the replicas, but almost every single one of those Prometheus deployments was a little bit snowflakey. This is something that can happen over time. And so trying to really understand our total metrics volume, it wasn't going to be a one-to-one. We didn't need to migrate everything from on-prem Prometheus because it was a total dumping ground, which is why it fell over all the time. So going across to Grafana Cloud, I basically had to just generate a spreadsheet of all of the metrics that we were using across the company, and I went through it by hand and just went, no, yes, okay, maybe, no, which isn't super scientific, but it got us through for a little while. Yeah, in terms of what we want to do in the future as well, the thing that we're kind of looking at the moment, we are using the Grafana SLO product, and it's been quite cool as part of our relationship with Grafana, is that we're actually able to, that they're willing to work with us, and we're able to provide feedback on new projects and products that they're developing. So yeah, we were sort of heavily into SLO before it was released, and we're now looking at, can we sync between the SLOs? So if a team sets up an SLO that says, actually 400 milliseconds is a slow operation for us, can we sync that into tail sampling so that we make sure that anything that's over 400 milliseconds is sent to Grafana Cloud for review? Because the concept of a bad trace that needs a review is different and can be completely service specific. I'm rushing through the last couple of slides here. And yeah, I think in terms of where we've ended up now, we've ended up with an observability vendor, and that has a really great culture match with us internally. Very important, because it's our second biggest contract after our cloud contracts, to give you an idea of the importance of this relationship. And this was why it was so disappointing to see it sour before when we were with the previous vendor. But also really nice to see that we're now with somewhere that we're really happy, and we're able to kind of work together into much more of a partnership. And I think, there you go, that's my final slide. That was a fairly okay one from the AI tools, I think. But like I said, so this has been a really, really swift whistle-stop tour, slightly meandering, a bit disorganized. But yeah, I'm really happy to talk about any aspect of this much more in depth. If you want to grab me, I'll be floating around for the next couple of days. But apart from that, I think I'll end it there. And yeah, thank you.